Radio engineering, graphics and design learners, ladies and gentlemen, this is it, grade 12, mechanical analytical, and this lesson is going to set you up for success. So please help me out by paying attention from the very start. We're in the HSE workbook on page 26, and of course, regardless of the workbook that you're having, this is going to benefit you. So please help me out and pay some good attention. Those of you in class, let's get going. So first of all, this is going to be a part of your examination heading into, of course, finals. Definitely going to have a mechanical analytical. And I love the way that HSE is asking these questions because it's very familiar to what you're going to expect in the final exam. All right. So they've given you a incompleted assembled view, sectional front view. It's incomplete here with a lot of references. At the bottom here, there is a parts list. We've got the traditional title block with a lot of information, projection symbols, a couple of things, and then the questions on the right-hand side. Now, I'm going to be reading the questions, but I'm going to be zooming in on this part here and try and ensure that you stay up to date. Okay, so as ons so tussen Afrikaans en Engels gaan, ek wil graag hê dat jy nou saam met my hierdie voltooi. Alright, so kom ons kyk. They first of all ask us to insert an M20 bolt and nut in the top half of the assembly. Both the bolt and nut show three faces. All construction must be shown. Now, they've given us the bottom half. We need to do the top half. They've also given us the center for the auxiliary view. Ladies and gentlemen, when you get to the exam, you don't have a reference now to sizing charts, etc. You have to use what is given. Now, first of all, I'll make some notes here on top. This is an M20 bolt. Okay, M20. Wat weet ons van 'n M20? Wat beteken daai 20 daar? That is your diameter. Okay, so we could as well as replace that with D for diameter. All right. Now, because they've given us a bolt in the bottom half, what we can do is we can just project upward the depth of each one of these components. So that's a bolt head. We're going to project that up. That is, of course, aligned. That's the easy one. And then the same this side. And if you are in class, please draw with me. All right. Okay. If they did not give us a bolt head, you need to know the different formulas. Okay. To determine the depth of this nut, what is the formula? Can you remember? I'll just make an arrow here. D times 0.8. You have to know that. The bolt head, that's the nut. This side, the bolt head, it is? Thank you. I'll just make another reference here. That would have been 0.7 times D. And I'm doing that for those of you who don't remember this. The depth there, the standard depth is 0.8, 0.7. I actually did the calculation. If I times 20, which is the M20 bolt, with 0.8, I get this exact depth, the same with that head. Okay. The next part here is to do our auxiliary view. And here again, there's a formula that you have to know. And that is to get this started, we need 1.5 times D as our start. So we've got a 20, that's going to be a diameter of 30. This drawing is done, scale 1 to 2. Okay, moenie dit mis nie, skaal 1 tot 2. Dit beteken, as ek 1.5 maal D en die diameter is 30, then I'm going to work with a diameter of 15, which is going to be 7.5. I'm going to use my stencil here because my compass struggles to draw a diameter 15. So remember, this is only 15 millimeters, diameter 15, because we're drawing scale 1 to 2, half scale. But the actual measurement here is 30, because I'm using this formula of 1.5 times D. Am I too quick, or are you keeping up? Julle by? Ek teken mos nou half skaal. 1.5 maal D is 30, daai moet 30 wees, maar is half skaal. So dit raak dan 15, okay? Right. Then on the outside of that, we're going to draw our three sides of our bolt. So at 30 degrees, 30 grade, on the outside of the circle, aan die buitekant van die cirkel, raaklyne. Okay, just in construction. What that does is it creates for us the height here. Okay, so I'm going to project that back to get this end and that end. Project this one back, that and that. Same on this side, and same on this side. Right, and now I'm going to zoom in again because I want you to see the construction method here. Alright, so using my 30-degree triangle, from the outside, we'll just do one at a time. From the outside, flip it, should line up, and then the small part here, flip that, and the small part here. So that has helped me to get these 3 points. Yes? Alright, I'm going to use my compass now, and I'm going to set it on that center, and then project that to get that first arc. Okay? Then I'm going to go to get the smaller one. Oh, this is so small. Alright, and you're going to draw that arc. Let's see if my compass allows that. Ooh, I'm going to have to use a different plan here just for the sake of sizing. Sorry, ek trek nou net want my passer wil nie daai bogie trekkie. Okay, so you're going to draw an arc that touches your 60-degree angle, and then you're going to do a flat chamfer on that side at 60 degrees, same on this side, and you are going to join the top of it. So very quickly, the bolt head is drawn. Let me show you quickly a real bolt head, and you can see the similarities there. Do you see that? Okay. So you've got your 60 degrees on either side. You've got your 3 faces. Alright, you can do the same for the other side. So using our triangle, 60 degrees. Alright, I did that to determine these 3, and I'm going to again use that to get my various arcs. Okay, try and use your compass. I'm again using this because I can't fit this in with anything else. Let me see.
So,
yeah, Messian.
What is that radius that you use there on the circle?
That's what I just drew. Well, technically it's this radius. From there...
Oh, no, not that radius, the circle that you drew on your right.
On the right hand side. Young man, it was the 1.5 times D. Okay. And then I said, this drawing is done scale 1 to 2, which means 1.5 times D, which is 20, is 30. Diameter 30. But scale 1.5, 1 to 2, it is 15. So that's 15. Okay. Alright, let's finish this part here. Okay, the other part here is the actual shaft on the inside that we have to draw. Now I can use the measurements that's given here. That's going to be 10 because we're drawing, there you can see it. That's a 10. We're drawing scale 1 to 2, so technically it's 20. Alright, there it goes. Okay, and then projecting our screw thread from, let me zoom out a little bit. Okay, so I'm just duplicating this screw thread. There's the line. Drawing that in. And then my screw thread. Screw thread. What's the formula for screw thread? Remember? 0.1 times D, which is 2 millimeters. This being half scale, is going to be 1 millimeter. Yes or no? Ek hoor nie genoeg ja's nie. Are you with me? Okay, and 60 degrees this side, 60 degrees this side. What's missing here is the end, the shaft. So we'll just bring that across, across, and across. And then project from the bottom here up. That corner is a 45 degrees. Okay. All right, so you've copied what was given to here and you've done your auxiliary view. All right, that was the first M20 bolt. Remember, this drawing is done at half scale, so if you were confused. Then they ask us to project a right view, number 2, of the bolt and nut assembled on the given center. Project a right view of the bolt and nut assembled. Project a right view of the bolt and nut assembled on the given center lines. Well, that's what we did here. That's that auxiliary view. So we can, sorry about that. We can just go and finish that. Let me do that quickly for you. Okay, so luckily the auxiliary view is already part of that. What's going to be something that we're going to add here? We're going to have to add this screw thread. All right. So we're taking it from this side. We can project it all the way to there. We've got to have the screw thread there. Okay. All right, so let's do the outside first, the actual screw thread. Okay, no, sorry, that's the shaft, the outside of that shaft. Take it very slow. Ooh, some movement, sorry about that. Okay, and then our screw thread goes on the inside. So I'm going to, sorry, my compass is so poor. Let's see if I can use my stencil. And so that screw thread has got to have an opening. Just keep an eye on that. So there's an opening there for that screw thread on the inside, and then the outside, that's your shaft. So if you line that up, it should go with the outside, inside. My accuracy is a little bit out because of that compass of mine, and this being very small. But the look of that has a screw thread on the inside that's not closed up, and then the outside is your full one. All right, happy? All right, let's go to the next one. Project the right view of the shaft on the given center lines. Do not show any details. So our main part here is the shaft. I've already started projecting across. We've got the outer diameter, which is a circle. If I look at that shaft, all right, it's going to be a big circle on the outside. All right, then on the inside, we've got a square on a shaft. Do you remember the flat surfaces here? Okay. So we're just going to do a circle, first of all, on the outer diameter here. Construction, you can do it in construction if you want to. Okay. And then this part is the 45 degrees from here to here. So you can see that there's a round there. That's that part. And then from here, there's a 45 degree flat surface. So it goes flat this side. Then there's again an arc. Then there's another square part. That's where that line comes through. Another square or flat surface. So flat surface all the way around. Okay. And then you can go back and you can finish the arc part there. It's on this. Why is this moving? Okay, so I hope it's clear enough. You have a flat, that's that. Then this part is that circular part. On top, that darker line is that arc and that arc. So all I did is I projected this bottom across and the inside across to get the points. Okay. Right, and then we have a shaft end that's also part of this drawing. So projecting that across and that screw thread. Okay, so again on the outside, it's going to be a full circle. And then on the inside, a half a screw thread. That Okay, let me show you the picture so that it's a bit clearer for you. I don't want to confuse you. Alright, there's the actual answer. So if you take a moment to look at that. Okay. Sorry, my accuracy with this compass is dire. Alright, there we have it. Inside is a screw thread, not closed up. Then the outside of that shaft is this full circle. Then there's the flat part that we actually see here. And those lines that's projected across to get those little arcs. Does that make sense to you? Okay, look at the right view also of our nut. Right. And then the shaft with that screw thread sticking out there. Okay. Right, those two you need to be able to draw. Let's look at the rest of this question because it only gets better from here. Alright. Insert the hatching on the flange coupling. Now they want us to finish this view. So what is a flange coupling? We've got two flanges. They are bolted together. There's a key and a keyway that's helping transfer the rotational force from this shaft onto this flange, through the keyway back to this shaft. Do you see that? Okay. So, and there's an air cavity in between them. So we've got two shafts that's actually joined together to transfer rotational force. Okay. So we've got two main components here. You're going to use your 45-degree triangle and you're going to do your hatching, and your sizing here can be nice and big because I don't want to waste your time. You also don't want it too close because then it's going to waste a lot of time, but you want it to be evenly spaced. Okay. Evenly spaced all the way through. Okay, so you're going to do that. What do we know about two components that's adjacent to each other? Wat weet ons van twee dele wat aangrensend aan mekaar is? Die arsering moet verskil. Die rigting van arsering moet verskil. Okay, so we can actually just flip that. And let's see if I can. You can continue upwards. Okay, that's the main component. What else do we need to hatch? Here we have a keyway with a key, so we need a partial section. So with freehand, any 45 degrees here. Now the spacing needs to be different because it's just next to that one. I could have actually changed the direction completely if I wanted. But this is a partial section. In Afrikaans is hierdie 'n gedeeltelike snit. Dis 'n vryhandlyn en dan 'n 45 grade. Okay. Wat moet nog gearseer word? Wat van hierdie einde van die as wat 'n S-breek is? S-breek of 'n onderbroke aansig of 'n interrupted view. Okay, that needs to be hatched. Right, let's look at that. Is there anything else here that we're missing with regards to hatching? All right, that looks fine to me. All right, then the next one. What is the purpose of the flange coupling? Wat is die bedoeling van 'n flange koppeling? Ek het klaar gesê om rotasiebeweging van een as oor te dra na 'n ander as, nee, dis daai koppeling to transfer rotational force from one shaft to the next shaft. That's what a flange is used for. All right. What is the drawing number? Where will the flange? Wait. Let's do number 6. Sorry. What is the flange coupling? Will the flange coupling be shipped as an assembled unit? Wat dink jy? Sal hy as 'n saamgestelde eenheid verskeep word? Onthou, Wilmer Industries is making this flange coupling. How will they ship it? Will it be assembled? Why not? Because what about the shafts? Okay, can't be assembled. It will be shipped in different components and only assembled on site. Nee. Next question. Where will the flange couplings be shipped to? So if you look here at the bottom, you've got the producer, who's Wilmer Industries, and then the client is Sascom. Okay, so that's where it will be delivered to. Shipped doesn't necessarily mean on a boat, it just means delivered to. All right. Next question reads, will the flange coupling be shipped as a... We did that. Where? We did that. What is the drawing number? So the drawing number here is at the file name, 207 312 7702. Including this finished revision, how many times was this drawing revised? If you look at the alterations here, 1, 2. There's been 2 alterations. Nee, 2 veranderings wat aangebring word. Alright. Waarom is die opskrif wys, waar kan die antwoorde vir die vraag bevind word? Wel, hier by verwysigings or at alterations. Then the next one, why is the heading alterations placed at the bottom? Hoekom sê hulle wysigings en werk dan op? Julle weet dit. Yes. Ja, it leaves space to add more. Nee, ek kan nou nog meer hier byvoeg. Waar as alterations bo gestaan het, dan was ek gestak met plek. Interesting question that they asked there. Alright, who made the drawing and when? So it was drawn here by NH and you see the date there. Alright, what is the name of the manufacturing company and when was it established? There we see Wilmer Industries and the date it was established. There's a couple of good questions coming, so hold on with me, keep with me. What is the dimension unit? Wat is die afmetingseenheid? En dit is natuurlik millimeter. Daar kan jy dit ook sien. Millimeters. Okay, what material must be used to manufacture the shaft? On our parts list, you can find the shaft and you see there it is nickel chrome steel. How many different components were used in the assembly? Oh, great question. How many different components? So you can go count. 1, 2, 3, 4, 5, 6, 7 different components. The next question asks, how many components in total? For that one, you have to count all of these together. Ne? And that's 10. All right. Then, number 18. What is the length of the bolt? All right. Take a deep breath because now you have to be excited and read. They ask us, what is the length of this bolt? So you're going to, well, you can use scale 1 to 2 because that's the scale if you have a scale ruler. If you take from here to the end there, it is 48. Okay. If you have a scale 1 to 1, just a regular ruler, you're going to measure that and you are going to see it is 24. What do you have to do then? Times it by 2. Because this is drawn half scale. They don't give you the measurement anyway. You have to go measure it and then remind yourself it's scale 1 to 2. So if it's 24 scale 1 to 1, it will be double that, because remember this drawing is half the actual size. Nee? Is julle nog by met my? Okay, en die lengte van die bout word gemeet van onder die boutkop tot die einde. The length of the bolt is measured from the underneath the bolt head to the end of that screw thread. Okay? How many different fasteners was used in this assembly? Now, to answer that question, you need to know what is a fastener. A fastener is anything used to keep this together. And if you look at it, we have a bolt. They're asking again how many different. We've got the bolt and we have the nut. That's already 2. And we have a key. You can look at that. There's no other fastener. So it's 3 different fasteners. The next question asks how many fasteners in total. Well, now we have to know how many nuts, how many bolts, how many keys. Now you can go count them, but let's say there were maybe bolts and nuts hidden. It would have been difficult for us to count them all. So you're going to go back to this list here, and you can see there that there is 2, 2, 2, that's 6. Alright, so boute, moere en 'n spy. 6 in total. Okay, right, good. What feature does A represent? Okay, let's look at this. This is straightforward. A here is a chamfer. That's at 45 degrees. Afkanting in Afrikaans. Afkanting. B is a skroefdraad, screw thread. C is a flat face on a shaft. Plat vlak op 'n skag of op 'n as. Sorry, plat vlak op 'n as. Ons weet dit met daai kruis. That cross there shows that surface is flat. D here is a round. Buiteronding. Of a ronding. Okay. I'm going to quick because this is straightforward. E is a fillet. 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 Alright. Then they ask, what feature does F represent? That is our, where's F? Oh, there it is. We're looking at that circle. That is an interrupted view or 'n S-break. Onderbroke aansig of 'n S-breek, né? Alright, then G here is 'n keyway, spygleef. H is die verwys eintlik na daai gedeeltelike snit, partial section, gedeeltelike snit, partial section. E is a lugholte, air cavity. Remember, where those two shafts meet, there's going to be a air cavity. And then let's go on. They now ask us to determine the following dimensions. So they start here with J. So if you have a scale ruler 1 to 2, it's going to be the easiest because you're literally going to take it there and you're going to measure it and see that that is 40, diameter 48. You have to write that answer as a diameter 48. Can't just write 48, diameter 48. Again, if you don't have a scale ruler, you're going to use scale 1 to 1. You're going to find it's 24, but then you have to times it by 2. Okay, let's try and use the scale ruler. It's going to be the easiest. The next one is K. That is going to be 896. L there, 216 diameter. And M here at the bottom is our 80. Okay? Let's check. If 1 inch is 25.4, so 1 inch is 25.4 millimeters. They're asking us how many inches will be the total length of L. Now L was diameter 216. So what you have to do is you have to take that 216 divided by 25.4, okay? And that's going to give you 8.5. Oh, sorry, look at my 5. I say 5 and my hand writes 8, okay, 8.5. So it is in total 8.5 inches. Does that make sense to you? So you just do a conversion between 1 inch. If 1 inch is 25.4 millimeters. If I've got 216, then how many inches it will be? 8.5 inches. Alright, if a scale to 1 to 10 were used, what would dimension L read? Oh goodness, good question. If we use scale 1 to 10, what will this dimension read? It is reading diameter 216. What will it read if it's scale 1 to... This is now scale 1 to 2. What will it read at scale 1 to 10? Come with confidence. Wat gaan hy lees? Hy lees nou 216, diameter 216, maar dit skaal 1.5, 1 tot 2. Wat gaan hy lees as dit skaal 1 tot 10 is? Kom mense, selfvertroue, jy is graad 12. Nee, Corneels, 216, it's not going to change. The dimensions here does not change. They're trying to catch you out. Doesn't matter the scale. The dimension that you write does not change. It's the actual drawing that changes when you draw. Yes or no? Yeah, means okay. Last one, second last one. In what formats were the drawings saved? So if you look here at the bottom, it was saved as TCW and DXF. And the last one, what does the file extension DXF stand for? It stands for Drawing Exchange Format. drawing exchange format. Dit is in Engels en Afrikaans dieselfde. Okay. Alright. Happy? That is then page 2.6. It was quite a lengthy one. You please need to do for the next lesson 2.7 and 2.8. Righto, thank you for watching. Now it's your turn.